What's poppin', dogs? Mr. Allen here with a little challenge problem, a geometry challenge problem involving a circle and a few tangents, and we're asked to find the perimeter of triangle ABC, but all we're given is the length of AD and AE being 20. Interesting. Now, if you want to try this one on your own, go ahead and pause the video and have at it. But I'm going to start solving this bad boy right about now. All right, this was brought to me by a student in the comments, and they were like, hey, how do you solve this thing? And I'm going to be honest, I was stumped. And I think that's what I love about geometry is it still stumps me from time to time. So what do we know about tangents and circles? Well, if I have a tangent line or ray or segment, right, from the points of tangency to that external point out here, these two segments are going to be congruent, as will these two. But we don't know if all four of those are congruent to each other. It's just these two are congruent and these two are congruent, as is AD and AE, but that should be evident there is that they are both 20 and they would follow that same pattern. Okay, now it's important to note that this point F could be actually anywhere along this circle between E and D on this arc, and this whole thing would still hold true, okay, which is kind of crazy because right now it looks as almost like ABC is like an isosceles triangle, but we don't know that, right? We don't know that for sure. There's no information that's given to us about that, and that's a common issue that people have in geometry is they start assuming things they cannot. All right, so what do I do here? Well, this length right here is 20, and then the same goes with this guy right here. Let me get these teacher brackets running through here. Whoop! This is also 20. Okay, cool. Well, let's see here. Let's see. Check this out. I know that this segment AC plus this segment CE, that equals 20, right? And I'm gonna jot that down, okay? AC plus CE equals 20. Cool. Could I say the same thing over here? AB plus BD. AB plus BD. That equals 20. All right. Well, where are we going with this? Because the common thought is like, oh, should I draw in some lines? You could. I could draw an OE and I'd have a right angle. I could draw an OD. I'd have a right angle. I could draw an OF. I'd have a right angle. However, we don't know if A, F, and O are collinear, so I can't draw that straight through. But back to this whole little dealio here. I'm going to write down some other information. I do know that CE and CF are equal in length, right? So CE is equal to EF, right? CE and CF, sorry, CF. And I also know the same is true over here with BD and BF, right? Those guys are equal as well. Okay. Well, hold on. Could I? This is AC, and then I have CE. Could I substitute CF in for CE? And I'm going to do that here in, how about green, okay? So I'm going to take this guy right here. I'm going to substitute it in right here, which means it's this length right here that I'm talking about, okay? So I'm going to take this statement right up here, and I'm going to substitute CF into CE's place, okay? So I'm going to have a new statement, AC plus, let's do this guy in green here, CF, and that's going to equal 20. Okay. Cool. Now, let's apply the same idea over to this side, okay? The same idea over to that side. And I'm going to switch to, let's go with blue this time. All right? So I'm going to have this guy right here. And I'm going to take, so BF, right? I'm going to substitute that in place for BD in that statement. So I have AB plus BF, right? BF is being substituted in for BD, substitution property, coming in clutch here, equals 20. Now, correct me if I'm wrong, but is triangle ABC made up of AC plus CF plus FB plus AB? Are all those part of triangle ABC? Absolutely. Right, this right here is just that side CB, right? but I broke it into two parts. Well, if I were to take now all of this, right, all of that right there exists right here. AC plus CF plus BF, or FB, plus AB. Boom. All of those right there. So this is going to be 20 plus 20 equals 40. That's pretty dope. That's pretty dope right there. All right. So it does not seem like you have enough information to solve this problem. But then with a little bit of substitution method, bing, bang, boom, we've got the perimeter of triangle A, B, C. No sweat, man. No sweat. It's pretty impressive how much hidden math is in these circle problems. And again, this one stumped me, right? I was looking at this. I was drawing in like lines here, here, here. I'm like, what can I do? Can I get some different variables going on? A lot of these are so dang simple. It's frustrating, but it's fun. It's kind of cool to attempt these things, and they're real brain busters. Anyways, hope you guys like that one. I enjoyed that one. Obviously, I'm big into math, big into circles. It's one of my favorite shapes. But thanks for watching, you guys. Have a wonderful day. If you got any other challenge problems you want to throw my way, let me know. Pop a link in the comments, or I don't know how you would share it with me, but figure it out, okay? Because I love good math problems. See you later.